Cycloalkanes. What are they? Well, cycloalkanes are hydrocarbon chains which connect in a circle. So, for example, let's do propane. Now, we already know how to draw just propane, but we want to draw the cyclo part. So we take the cyclo part of cycloalkane, put it right in front of the propane. Cyclo. That way it makes cyclopropane. Now how to draw it? It's pretty simple actually. You just take H2C because it's written like that on that side. And then you write CH2. And then you come down here and write CH2. And you go back up. So it's making, that way it looks like it's making its full circle. And so now how we can check if it's right is that we know that propane is written as C3H6. So we count how many C's we have. 1, 2, 3. So we're good for there. Now we count how many hydrogens we have. So we have 2 there, plus another 2 is 4, plus another 2 is 6. So that way we know that we're good there. Now we count how many hydrogens that we have. So we know that there's 2 over here, plus another 2 makes 4, plus another 2 makes 6. So all in total, that is correct. We have our 6 hydrogens and our 3 carbons. So let's do another example. So let's do pentane. So that we know that we have to do pentane, that's our given one, then we have to write cyclo in front of it, so we do cyclo. So now, how to draw it is simple. We just draw pentane. So think of it as the Pentagon in the United States or something. It pretty much looks like that, except for it's going to look like this, H2C, come up, and then we go CH2, come down, another CH2, and then come down again, and that does CH2 again, come down, and then we write H2C. So that way, it somewhat looks like a pentagon. And now that how we know we can check it is, we know that pentane is C5H10. So now we count how many carbons we have. We should have 5. So there's 1, 2, 3, 4, 5. So we're good for carbons. Now how many hydrogens we have? Well, let's check that out. So we have 2 here, another 2 over here, so that makes 4. Another 2 makes 6, another 2 makes 8, another 2 makes 10. So we're good for that. Cycloalkanes have a similar general structure like alkanes, and so what the general structure for cycloalkanes looks like is Cn plus H2n, and so it's the same thing as N is equal to the number or the amount of carbon atoms that are going to be, and the lowest carbon atom, or the lowest cycloalkane is cyclopropane. So if we had, let's say, N equals 4, and so we fill it in, the blanks, and C4 plus H2 bracket 4, and so let's fill this in, C4 plus H, 4 times 2 is 8, and so there we go. And we know that it's going to equal to cyclobutane. So let's do another example. So if we had N equals, let's say 9. Excuse me. So we need to write out our formula. Cn plus H2N. We fill it in. So C9 plus H bracket 2 bracket 9. And we keep on filling it in. So C9 plus H. And 2 times 9 is going to be 18. And so we know that this is going to be a cycloalkane. Table to help you understand the different formulas there are. So if you saw the molecular formula and it was asking for the line formula, that'd be simple. If you didn't know it, you can write down your given. So it's C3H6, and then what that's going to look like is just a triangle. Let's say you had the molecular formula for C6H12, and you're wanting to know the structural formula. So you can write down your given already, and that's C6H12, and then you just draw it out. So it's pretty much your line diagram that you see right here, but you're filling in with all the CH's. So let's draw that. So there's going to be H2C, then goes up, CH2 goes up, CH2 comes down, CH2 comes down, CH2 goes across, CH2, and then goes back up. So that way, now to check it, you can show that we need 6 carbons. So let's count. There's 1, 2, 3, 4, 5, 6. So we have our 6 carbons. Now we need our 12 H's. So you pretty much count around. So we have 2 over here. Another 2 makes 4, 6, 8, 10, and 12. So we know that that's right. So now if we had, let's say, the structural formula of cyclobutane, we want to know the molecular formula without knowing it, we would first write out our given. So that's H2C, and then CH2 comes down, CH2 goes across, H2C goes back up. And so we can pretty much know, well, we can not know, but we can count around. We have 1, 2, 3, 4 carbons. So that we know that that's going to be bute. So we can write butane, and then we have to make sure that we're correct. We count how many hydrogens we have. So we have 2 over here. Another 2 makes 4. This makes 6. This makes 8. So we know that that is right, and that it does equal butane. And we just write the cyclo part in front of it.
Made with Doodlecast Pro.